Before we get started, I probably noticed I forgot to tell you on the first lecture where you can find these notes on Dropbox, and it's http://db.tt/Z6 capital W capital Z lowercase I capital W capital V capital T. And you're probably thinking, well, I've been through this, I know what that means, and you've probably done it. But just in case, there's your notes for this one. Okay, let's go to lecture 2. And you're thinking, oh my goodness, another equation. Well, all these equations is just a derivation of the ideal gas equation. This is more direct, where what we did was that N is equal to how much you have divided by the molecular mass, and that's kind of a script M, and then just rearranged it to solve for the M. Another way that you might see this, okay, M over V. I remember that from fluids and temperature, and that is density. You might see this as dRT over P. Units are still the same. Mass is in grams. So how can I know where to use this one? I'm going to either look for grams or molecular mass. One of those two will be in the problem to use this equation. Yes, we can use that ideal gas equation. Remember, that's moles. Can't use this one as such. But we can still use the ideal gas equation for this one. But this is more direct, so if you see grams or molecular mass, we're going to use this one. Remember, all the units will still stay the same, temperature, volume, and pressure. So, okay, so let's write down our equation. mRT over Vp. Okay, we've got grams, molecular mass, so we got to use this one. Okay, so molecular mass. Okay, that's 0.45. Okay, R, it still hasn't changed. Remember that temperature always has to be in Kelvin. Volume is in liters. Now, you can put 0.275, or you can divide it by 275 divided by 1,000, doesn't make any difference. But remember that millimeters of mercury has to be in atmospheres, so 756/760, and there it is. So really, we haven't done anything different than we did in the ideal gas equation, and M is in grams per mole. That wasn't bad, was it? Well, let's look at another one. Okay. 0.25 gram gas sample. Okay, there's a gram. Molecular mass. Normally, your teacher may use MM or M to denote the molecular mass, and some of them might be mean enough to make you actually calculate the molecular mass, especially if you're doing this in chemistry. So M is equal to mRT over Vp. Make sure that P is, oh, there we go. Okay, so I gave you 56, and all we're doing is just putting our numbers where they have. And if you've been following along, this is probably the hardest part, the substitution. And so I bet you some, yeah, you're right. And there's 45. But if you know your units, so V, don't forget that's 500 divided by 760. If you know your units, you know where to put stuff in. Yes, there's the dimensional analysis factor label method that does work, and I still use that sometimes, but especially if you have an equation or a formula, go with, if you know your units, you know where everything goes. So volume is in liters. Okay, of course, I do make mistakes. Y'all know that. This last one, you notice, you probably think, oh, where's the volume? So you could put, I just plugged in 1.5 liters, or if you want to kind of play with it, You can put any volume you want. Let's just do another one just to kind of make sure everybody's on the same page. Okay, molecular mass. Okay, that's normally what you would use this for. Okay, so M is equal to MRT over. Now you want to make sure that this is a capital M and this is a lowercase m, so please make sure on that. Okay, so I want the M, and a lot of times you will see that this is more of a kind of a script flowery type M in your textbook. Okay, there's the grams. Okay, 08206. And okay, we've got kind of a 273. And the volume, okay, now I'm just going to move the decimal place over 3 times to the left. And don't forget that millimeters of mercury has to be divided by 760. And that M is equal in grams per mole. And there it is. That's pretty much it. So on this one, this equation, if you see a gram, which is the mass, or you're looking for molecular mass, or you see it in the problem, this is your equation you're going to use. M is equal to MRT over VP. If you see a density, this is the one you're going to use, because that's usually how some books will show this. Real straightforward, isn't it? That's one thing good about gas